Good afternoon, everyone. This is just to give you a recording notice. This lecture is being recorded. If you have any concerns, you need to email me, please. Now, today we are going to solve another example for joint probability distribution. So we are going to have an example for joint probability distribution. The time to produce a typical engineering drawing represented by a random variable and this I'm denoting as X. And its quality represented by a random variable y. This variable I'm denoting it as y are under consideration. For those of you who are joining us now, so we are doing an example for joint probability distribution. It says that the time to produce a typical engineering drawing represented by a random variable x and its quality represented by a random variable y are under consideration. Now the x can be x can be 70, 80, 90 and 100 hours, because this is the time you have the units of time, hours. The quality of a drawing can be considered to be moderate good, and excellent. And Y can be 1, 2, and 3 respectively. Now, what this statement means, if you have the quality of the drawing moderate, I will take my random number Y as 1. If the quality of the drawing is good, I will take it as 2. If the quality of the drawing is excellent, I will take number Y as 3. If 100 such drawings are evaluated, the following table is constructed. So in the next slide, I'm going to write down the joint probability table for this problem. Oops, I need to go to the next slide. So I'm going to wait for 5 seconds now. Now we had two variables. One was X and our second variable was Y. This is the table of the joint distribution we discussed last time. So these are the values of the Y, 1, 2, and X has 70, 80, 90, and 100. Now, if X is 70 and Y is 1, this value is 15, which is given to you in the statement. This is 3, this is 5. Corresponding to X 80 and Y 1, the value is 8, 4, and 8. Corresponding to X 90 and Y 1, the value is 3, 6, and 12. Similarly, if I have X is 100 and Y is 1, my value is 2. This value is 12 and 22. Now we have 4 objectives here. The first is plot the joint probability mass function, which is PMF, of X and Y. This is our first objective. The second objective is plot the marginal PMF, probability mass function, of X and Y The third objective is if only excellent quality drawings are acceptable, by that I mean to say my y, the random variable y, that should be equal to 3. He's saying to plot the conditional probability mass function of X. Folks, I need to go to the next slide, please. Sorry, this should be plot. Plot the MF of X. Fourth objective is determine the covariance of X and Y and the corresponding correlation coefficient in X and Y. Now I'm going to start its solution here now. Now I'm going to redraw that table that we have in the previous slide because I need to use it again. So this is my value of X, for example. This is my value of Y. So at X is 70, 80, 90, and 100. Whereas the Y are 1. This is the same table as was given in the question statement. See, 8, 4, 8. This value is 6 and 12. And 400 we have 2, 12, and 22. So this is the joint probability table. Just for your reminder, if I take any value, let's say I take this value, this is the probability value E of X of Y. When your X value, go on the top, the X value is 80 here, and y value is here, which is 3. So this value is p equals to 8, just for your reminder. Now what it is saying, how do we interpret this table? You can say that there are 15 drugs which took 70 hours to produce with a moderate quality. That's how we interpret this table. Now the very first step that we need to work on is to convert these numbers in terms of the probability. Now we know that we have total of 100 drawings. So I will divide 100 with each and every one. So this table is going to convert into probability table. Again, this is my x and this is my y value. So at 1, 2 and 3, this is my 70, 80, 90 and 100. So what I'm going to do, I will divide each number here with 100 to get my probabilities. So 15 divided by 100, it is going to give you 0.15. 3 divided by 100, it is going to give you 0.03. 5 divided by 100, it is 0.0. Now in terms of 80, we have 8 divided by 100, you get 0.08. Here we have 0.04. This is 0.08. Again, 3 divided by 100, we have 0.03. 6 divided by 100, 0.06. 12 divided by 100, we have 0.12. Again, the same process, 2 divided by 100, I get 0.02. Here we have 0.12, and here we have 0.22. So the first step is we divide our numbers with our total number of the drawings, which are 100. Folks, I need to go to the next slide, please. Now, in the next slide, I'm going to plot this table. This table I'm going to plot. Okay, let's write it again, otherwise it will be difficult for you to understand. So this is my x here, this is my y. I have 1, 2 and 3. X value is 70, 80, 90 and 100. So the values I got in the last step was 0.15, 0.03, 0.05. These values I got 0.08, 0.04, 0.0, 0.03, 0.06, 0.12, and for 100 I have 0.02, 0.12 and 0.22. Now our first objective is that we need to plot the first objective. The first objective was to plot the marginal plot the joint EMF probability mass function of X and Y. Now by this I mean to say we need to draw this table. Now we have three here. This, for example, is my x-axis. Now this is the joint probability P of X of Y at X and Y. And this is my y-axis here. So this is a 3D graph. Now the very first point is X should be 70 and Y should be 1. So let's label them first and then we can see. For example, this is my X, which is 70. This is my 80. This is 90. And this is 100. And say for Y, for example, this is my 1. And this is my 2. And this is my 3, for example. Now, in order to find a point where X and Y coincides, we need to draw some axes here. So I'm going to change the color here. Now this is my x-axis here, and in parallel this y-axis, I have a line something like this. And this is, if I want to extend this, this will be parallel to the x-axis here. So this line will be a straight line from here. So the point where they are coinciding is something here. Similarly, I can draw for 80, which is going in parallel to the y-axis. This is for my 90. And this one is for 100. Coming back to when y is 2, you have this line here. Similarly, for y is equal to 3, we have this straight line here. If you understand how I draw this, then you should be able to draw the whole graph very easily. Now I'm going to change my color here. Now this point where I have x is 70 and my y is 1, this is 0.15, and this is the axis for your joint probability. So what I need to do, I will just go 0.15 above this line, just the rough estimate. And how I'm doing this, because this number I'm saying that is the 0.15. Now this point which I just find out is at x is equal to 70 and y is 1 here. Now let's go to the next point. It says x is equal to 80 and y is equal to 1. So x is equal to 80 and y is equal to 1 is this point here. This is my 80 and y is equal to 1. Now at this point, the height should be 0.08. So because this is the height of my 0.15, it should be lower than the height of 0.15, 0.8. So I just draw a little bit here. So this height is 0.08. So I'll write down here, let's say. Similarly, when I have x is equal to 90, my 1 at y is equal to 1, my value is 0.03. So this is my 90 here, and for x is equal to 1. So this point is my 90 and y is 1. X is 90, y is 1. At this point, my value is 0.03. So because it is 0.08, so this will be slightly lower than the previous one, 0.08. And the length of this is 0.03. Now, in terms of x and y is equal to 1, I have 0.02. Now, this is my x 100 and y is 1 coming from here. This coinciding point is 100, x 100 and y is 1. And it will be lower than the previous one because it is less value, 0.02. Okay, so I've write it down here, 0.02. This is how you construct the joint of x and y. Now the same procedure when you have y is equal to 2 and x is equal to 70. This is my x is equal to 70 and this is my y is equal to 2. They are coinciding at this point. Let me take another color here. Now at this point, I have my x value is 70, where y value is 2. So I go back to my table here. The value should be 0.03. So by estimate, I just draw it as 0.03. Now for the next value at x is equal to 80 and y is equal to 2. So this is my x is equal to 80 and this is y is equal to 2. This is the point which I'm talking about. So at this point, my x is 80 and my y value is 2. So this should be 0.04. This line should be slightly longer than the previous one because it has a higher value, 0.04. Now in terms of x is equal to 90 and y is equal to 2, this is my point here where your x is 90, your y is 2. The value is 0.06. It will be a little bit larger than the previous one because it is higher value. So it will be 0.06. In the last term, we have 102. This is the point that we are interested here. Here, your x is 100 and your y value is 2. So this value is 0.12. It should be larger than the previous one even because it's a higher value, 0.12. The height of these ones is associated with this axis. Now let's do for the last one. I will change the color again. Let's take this time. So in terms of x is equal to 70 and y is equal to 3, we are concerned with this point here. This is x is equal to 70 and your y is 3. And your value is 0.05. So I just draw my line here, 0.05. Now the next is x is equal to 80 and y is equal to 3. This is the line for x is equal to 80, and this is the point where we are coinciding both x's. So it is 80 and 3. The value here is 0.08, slightly larger than what I draw for the previous one because it has a higher value. It is 0.08, this value. Now the next one is x is equal to 90 and y is equal to 3. So x is equal to 90 is here. This is the point where they are coinciding. So I will say this is my 90 and 3. The value is 0.12. And x is equal to 100 and y is equal to 3. This is the point where we have 100 and 3. And the value is 0.12. So it should be a straight line. I will say it's 0.22. So this is what we call as the joint BMF of x and y plot. Folks, I need to go to the next slide, please. Now the second objective was to plot the marginal BMF as function of x and y. Now, in order to draw the probability mass function, first we need to find those values. Now, I'm going to do it for x first, and then I will do for the y. The probability mass function of x, for example, at x is equal to, starting at x is equal to 70. This is also written as e of x 70 is equals to, now the joint probability, this is the formula we did it last time, at x is equal to 70 and y. Now this should be sum up, because we are talking about x here, marginal probability of x, we need to sum up the values of y. Now you know that your y starts from 1 to 3. If I open this one, I will get the joint probability of x and y when x is 70 and y is 1, plus the joint probability at x is equal to 70 and y is 2, plus the joint probability when x is 70 and your y is 3. Now these values, we will go back to our table and write it down from that. I'm going on the previous slide to show you. So what I'm interested here, I need to find out at value of x is equal to 70 and y is equal to 1, what is my value? So I go back to my previous table here, probability table. So at x is equal to 70 and y is equal to 1, this is the value which I am concerned with. At x is equal to 70 and y is equal to 2, this is 0.03. At x is equal to 7 and y is equal to 3, the value is 0.05. So these are the values from the table. Now, in a similar way, we will find out the marginal probability for x is equal to 80, which means p of x at 80 is equals to the joint probability of x and y when at x is equal to 80 and the y value will be from 1 to 3. Now once you open this and find the values from the table, you will get your answer as 0.20. Now I'm going to write down the answers for the next one. At x is equal to 90, you have the p of x of 90 that will be equals to 0.21, and p of x at x is equals to 100, that is equals to p of x is equal to 0.36. Folks, I need to go to the next slide, please. Now in the next slide, I will write down the marginal PMF for y. Now when we are interested to find the marginal PMF of y, that means y starting from 1. This is equals to the joint probability of x and y. And because we are concerned with y, it should be sum of our x values. And starting from 70 to 100. Now this is the same as we were doing before. So at x is equal to 70, y is 1 plus the marginal joint probability distribution at x is equals to 80 and y is equal to 1 plus p of x of y when your x is 90 and your y is 1 plus the joint probability when your x is 100 and is 1. Now again from the same table, once you find out the values, it will be 0.15 plus 0.08 plus 0.03 plus 0.02. And this answer comes out to be 0.28. Now similarly, the joint probability, marginality of y when y is the 2. Once you find it, you will get 0.25. And for the marginal probability of y when y is equals to 3 is 0.47. Folks, I need to go to the next slide, please. Now let's summarize our marginal PMFs that we have so far. So this is the same table as we were doing before. This is my X here. This is my Y. This is my 1, 2, and 3. The X values were for 70, 80, 90, and 100. This is 0.15, 0.03. So you just need to plug in the same values as we have before. This one was 0.02. Now we find out the marginal probability of X, which is the P of X here. This value was 0.23. For 80 it was 0.20. For 90 it was 0.21. For 100 it was 0.36. Now similarly, we have the marginal probability of Y, which is P of Y. The value corresponding to Y1 we find out is 0.28. Corresponding to Y is equal to 2 is 0.25. Corresponding to Y is equal to 3 is 0.47. Now how do you check your calculations? If you sum up all these should add up to 1. If you sum up all of these should add up to 1 as well. So this one should come here. I add up all of these, got my 1. I add up all these numbers, I got my 1. So this verifies that my calculations are correct. Now I just need to plot. So the plot for X now the X I know it is 70, 80, 90, and 100. That's what I'm going to have it on the axis. 70, 80, 90, and 100. And here I have the marginal probability of X. Now this value at X is equal to 70, my marginal probability of X is 0.23. This is what I'm going to do. This value correspondingly is 0.23. At X is equal to 80, my value is 0.20. This one is 0. So I come back to here, and this is my 0.20, slightly lower than my previous value because it is 0.23, the previous one, and now it is 0.20. Similarly, at X is equal to 90, my marginal value is 0.21. This will be slightly larger than your previous value. So it is 0.21. For 100, I have 0.36. This is 0.36. So that's how you plot the PMF of X. Now for plot of Y, if this is my Y-axis and I know my Y values are 1, 2, and 3. These are 1, 2, and 3. And this is the marginal of Y. Now let's look at the values. For Y 1, we have 0.28. So with 1, I just went to, let's say this is corresponding to, for example, 0.28. At y is equal to 2, my value is 0.25. So this value is, for this point, it is 0.25. For y is equal to 3, it is 0.47. It should be larger than both of these values. Oh, sorry, it should be 0.47. Okay. Folks, I need to go to the next slide, please. Now, in the part C, he was asking if only excellent quality drawings are acceptable to 3, plot the conditional PMF of X. So what is our objective here? We need to plot our conditional probability when y is equals to 3. That's what we need to plot. First, we need to find out the values and then we will plot it. If you recall from our previous lecture, we had this formula. Conditional probability will be the joint probability distribution of X and Y. When Y was equals to 3 divided by the marginal probability. Because here we have X, we will have the marginal probability for Y. Now in terms of our X values, we have the conditional probability of X given that Y, when your X is 70 and your Y value is 3. So that should be equals to our joint probability value at X is equal to 70 and Y is equal to 3 divided by the marginal probability value of Y at now this value at X is equal to 70 and Y is equal to 3 is coming from the same table. So I will take you back to that table. Yes, here. So at X is equal to 70 and Y is equal to 3, this is the joint probability value, 0.05. Now this is the marginal probability of Y at 3. I will take you to the slide back here. This is find out 0.47. And you get your value as 0.11. Now with the same procedure, considering Y as equal to 3 but changing the X values, we will find out the rest of the conditional probabilities. At X is equal to 80, 3, Y is equal to 3. Now here you will get, I will just write down the final solutions here, 0.08 divided by 0.47. You will get 0.17. This is coming from the table, this value. Similarly, for conditional probability of X given that Y, and your X value is 90, given that Y is equal to 3, is 0.12 divided by 0.17, and you get 0.25. And the last should be your condition of X given that Y at the value of 100, given that your Y is 3, that is equals to 0.22 divided by, sorry, this one should be 0.47 divided by 0.47, and we get the value here for our conditional probability of X given that Y. Now the next step is we just need to plot this. So for example, this is my X value. So the X is 70, 80, 9, and 100. And this Y-axis is my conditional probability values of X given that Y. And this one we need to specify that your X given that Y is 3. This plot is when you have Y is equal to 3 only. So for X is equal to 70 and Y is equal to 3, I have value of 0.11. So I will draw it, suppose up to this point, assuming this is 0.1 corresponding to that value, and at X is equal to 80 and given that Y is equal to 3, 17, it should be slightly above this value. This is my 0.17. Similarly for 90, 0.25, and I don't have the values for this one, so you can check it what value will be here. That's what is the plot for conditional PMF of X. Folks, I need to go to the next slide, please. Now in the D, he was asking to find out the covariance of X and Y and the correlation coefficients. So for covariance of X and Y, this is what we did last time. Expectation of X times Y minus expectations of X and Y. Now these terms, these comes from the marginal probabilities. Your expected value of X is equals to X times the marginal probability of X, and we sum up all X values. For Y, we have the Y times the marginal probability of Y, and we sum up for all values of Y. And this term, we also defined it last time. This is equals to the product of X and Y multiplied by the joint probability distribution of X and Y because there are two variables, we sum up with the both, all x and all y. Now this one, e of x, so I need to multiply my x values with the marginal probabilities of x. So I'm going back to that table. I'm doing it. So this is my x value here. I need to multiply it with the joint, with the marginal probability value of x, 23. And similarly, 80 times 0.20 plus 890 times 0.21 plus 100 times 0.36. So I will just write it down here. 70 times 0.23 plus 80 times 0.20 plus 90 times 0.2 plus 100 times 0.36. So once you find it, you will have expected value of x is equals to 87. Folks, I need to go to the next slide, please. Now, once we have the expected value, we can calculate our variance here. Variance of x is equals to x minus mu of x whole square. We sum up for all value of x multiplied by the marginal probability of x. This is what we discussed last time. Now x minus mu of x, so the first x is 70 here. Value we just figured out, which is 87 square times the first marginal probability value constant x 70 is 0.23 plus your second term should be at x is equal to 80, should be multiplied by 0.20 plus 90 minus 7 times 0.21 100 minus 87 times 0.36. Now once you solve it, you will 139, and if this is the value of your variance, and for your sigma value, this is 100 and square root of 139, which gives you 11.79. Now similarly, once you repeat the same for your y values, I'm going to write down the answers here. Your expected value of y will comes out to be 2.19. Your variance of y will be 0.7139, and your sigma value for y is the square root of this number, 0.7139, which will be 0.845. Folks, I need to go to the next slide, please. Now, in case of expectation of x and y, we are using this formula as all x, sum of y of x and y times the joint probability distribution of x and y. Now, how we are going to write down here, I will take you back to that table now, please. Now, because x, y times the joint probability, it will be 70 times 1 times this value. For the next one, it will be 70 times 2 times 0.03. And these numbers should be added up for all the table. So it will be 70 times 1 times 0.15 plus 70 times 0.03 plus your last term will be 100 times 3 times 0.22 and get 195.1. Now our covariance equation, covariance of x and y, it will become the expected value of x and y, which is 195.1 minus the product of expected value of x times expected value of your y. This will be 4.57. Now, if you recall the covariance, we can also write it down as sigma of x of y. And for the correlation coefficient, rho of x of y, we have sigma of x of y divided by sigma of x times sigma of your y. This is 4.57. So sigma of x of y is 4.57 divided by 11.79 times 0.845. These are what we just found out in the previous slides. So your final answer comes out to be 0.46. This is your final answer, or correlation coefficient between x and y. Folks, I need to go to the next slide, please. Now, for your practice, from George and Douglas' book on page 150, try to attempt the problem 1 to 7 and 9 to 12 and problem 15. On page 150, problems from 17 to 19. On page 165, problem 34 35, and 39. And on page 177, attempt problem 67 to 69, 73, and 75. Now these seems to you a lot, but I did not give you any problems for the previous practices. Cover up your work. Folks, I will stop it here and I will take your questions if you have any. Okay, Hadis is saying it is 0.47. Yes, I fixed that, I believe, right? Folks, do you have any question for me? Any question for me? I joined late. Okay, Yakubu is saying I joined late due to bad network here. Okay, no problem. I will upload this video and you can go through it and let me know if you have any question after even. All right, folks, if you don't have any question, I will just let you go. And on Thursday, we will start a new topic. Thank you very much and see you on Thursday.